Okay, everybody, so I'm on page 83. Page 83. So open your books, and if you need to pause the video to wait, but you need to open your books to page 83, okay? Page 83. So when you get to page 83, it should look like this. What you have is two different graphs, two different parabolas, all right? So what we want to do is graph them. And I believe they might graph in two different places. Well, okay, so let's see. If I'm going to graph these, what I ought to do is get scales that work. So I'm going to get out my pencil, get out my ruler, looking for that stuff right now. Where's my ruler? Doggone it. I want to do this freehand. Okay, here we go. All right. Two different graphs. Let's take a look at both parabolas, okay? Well, let's see. I want to graph the first equation, y equals x squared plus 2x plus 1. I know it's going to have a y-intercept. I'll do this one in red. Y-intercept at positive 1. I know if I factor it, x plus 1, x plus 1, it factors into, I can get my zeros, okay? So my zeros are x plus 1 equals 0, or x equals negative 1. So it only has one 0, which tells me something about it. Okay, it tells me that that's also my vertex, right? So if I were to graph this, 1, 1, 1, 1, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, from the vertex 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it should look like this. Okay, give you a second to get caught up. So that's my first graph. I knew it had a y-intercept at 1, put a point at 1. I knew that if I wanted to find zeros, I could set it equal to 0, factor it. It's got to be an x plus 1, x plus 1. From many equations, I get x equals 1 twice. So x equals negative 1 twice, which tells me that that's got to be my vertex. In fact, I can figure out my vertex, negative b over 2a, but if I do negative b over 2a, I get negative 2 over 2 times 1, which is sure enough negative 1. Okay, all right. I know that it's got an a of 1, a value of 1, so that's where I went. The 1, 1, 1 squared, 2 squared, 2, 4, 3 squared, 3, 9, and the same thing, it's symmetric. Okay, now let's look at the second graph. So the second graph has a y-intercept of negative 3. 1, 2, 3. And I need more information, so maybe it factors if I can get some x-intercepts. Let's see. Let's try this. I think it does factor. I've got a 2x squared minus a 1x minus 3. If I set that equals 0, here's my second equation. I think that'll factor 2x, x, right? I think I need to go 3 and a 1 here. I need a negative 1, so I'd go negative positive. Okay, negative 3. Negative 3 times 1 is negative 3. And with my double smiley, it works. Okay, now these are going to give me my zeros. I factored it. And then I set these equal to 0. 2x minus 1. 2x minus 3 equals 0. Or x plus 1 equals 0. Okay, now, that means if I solve this from my mini equation, I get 2x equals 3 because I go plus 3, divide by 2, x equals 1.5. About there. Okay? And then x equals minus 1, minus 1. So I got a negative 1 right about there. Okay, so then if I graph this, it looks like it's about right there. Okay. If you're with me, then listen. It says solve each system of equations algebraically, then verify the solution graphically. Okay, well then, I know I've got one point that they intersect at, right there. One answer has got to be x equals negative 1. But there might be another answer, maybe up here, I'm not sure. So graphing is really about the worst way to do this. So how do you do it algebraically? Well, I'm going to scribble out B, and I'm going to show you how to do it algebraically, because I wouldn't want to graph this. So this is the hardest way, unless you have Desmos. All right, so what does Desmos show? Now, you can't use Desmos on the test, so wow, we're going to look at Desmos anyway. This is, you can't do it this way, but let's check it out. Okay, Desmos, I'm going to go y equals x squared plus 2x plus 1. Looks just like what I have, right? Ta-da, there it is. And then the other one is y equals 2x squared minus x minus 3. Hey, well, it looks just like what I have, okay? Now, I do see one point of intersection. That's what we're looking for, is we're going to solve this system. Solving the system is to find out where they intersect. Okay, so I've got one answer, is at -1, 0. That's one answer. I've got that, okay? They intersect there. There might be another answer, okay? I've got one answer. There might be another answer, maybe way up here. Oh, maybe way up at 425, okay? Way up there. Now, this is the hard way to do it. Now, obviously, Desmos is the easy way, but you can't use Desmos because I'm not going to let you use your phone, okay? You can't use your phone. Bummer. You could graph it, but that's really hard. Bummer. But maybe they're talking about algebraically. Okay, let me highlight that word. They want us to do it algebraically. Algebra. Algebra. Well, what does algebra mean? Okay, well, let's see. Let's see. Where the graphs intersect, right, where they intersect is where they are equal. All right? Where the two graphs intersect is where they're equal, okay? Where the two graphs intersect is where they're equal. So I know the answers because I use Desmos, but if I can't use Desmos, then how do I do it? I'm going to do it algebraically. So where they are equal, where they are equal. So I'm going to take my two equations and I'm going to set them equal. I'm going to take algebraically by algebra. Okay, I'm going to scribble out that. Take x squared plus 2x plus 1 and set it equal to 2x squared minus 1x minus 3. Okay? I'm going to solve for x. Okay? I do know there's two answers. We know that graphically, so I'm expecting two answers. So I'm going to solve for x. Now, solve. All right, well, I'm going to start with the x squareds. I've got a 1x squared and a 2x squared. I'm going to solve. So I'm going to subtract 1x from both sides. 1x squared minus 1x squared. I'm going to then have a 2x plus 1 equals an x squared minus an x minus 3. Looks to me like I'm probably going to need to factor. So because I have to factor, I need to make it equal to 0. Okay, equal 0. Okay, all right, so I'm going to subtract. I'm going to go minus 2x. And I'm going to go minus 1. And let's see what I get. 0 equals x squared minus 3x minus 4. And that will factor. That will factor. X multiples of negative 4. Negative 4 and 1 is going to be a 3. Negative 4, positive 1 will multiply to make a negative 4, but add to make a negative 3. Now, what I'm going to do next is my mini equation. So I get x minus 4 equals 0. And x plus 1 equals 0. All right, we're in Algebra 2, so solving is pretty easy. Plus 4, one answer is 4. Aha! One answer is 4. Minus 1, x equals negative 1. Aha! Negative 1. Now, what we need is their y value. So we know we've got an answer of 4 something and negative 1 something. So I need a y value. I need a y value. So to get the y value, we're going to plug these in. We're going to plug into Well, either equation, probably the easiest one is the first equation. I'm going to plug it into that one. I could plug it into either one, but let's plug it into y equals x squared plus 2x plus 1. All right, I'm going to plug them both. So I need two answers. So first, let's plug 4 in. So I'm going to go, all right, let's take the 4. We'll plug the 4 in, okay? I'm going to go y equals 4 squared plus 2 times 4 plus 1. All right, let's see what my calculator says. I know it's 16 plus 8 plus 1 is 25, by the way. 16 plus 8 plus 1 is 25. And what do you know? 425. There it is. So I've got an answer of 425. One answer. Point of intersection. Let's take -1 and plug -1 into here. So if I plug in -1 into here, I'll have a y equals -1 squared plus 2 times a -1 plus 1. Let's see, I got a 1 minus 2 plus 1. We're going to get 2 minus 2 is 0. 0, 0. What do you know? Haha, it is 0. So, to conclude, if you want to find out where the two graphs intersect, don't graph it. It's a pain in the rear. You could use Desmos. Desmos is awesome because Desmos is, I got the answer right away on Desmos. There it is. Boom, I just tap. Boom, I get my answer. Boom, I get my answer. But you can't use your phone on the test. So how do you do it? You do it algebraically. You set the two equations equal, and you solve. Simplify, solve, you factor, you get your mini equations, you get x values. I get two x values, but since they're points, I need two y values that go along with them, and that's how you solve it. Okay, that's what I have. Good luck. I'll see everybody on Monday.